Hi guys and gals. So we've got 4 goals today, and this will probably be a 2-part video situation just because I wanted to provide plenty of examples. And so this is section 6.6. It is the last section of Unit 6, which means next week you'll have your Unit 6 test. If you notice also on this week there is the Unit 6 review materials that you can complete. Remember, if you complete the review materials, if I'm feeling nice, I might give you some bonus points. Okay, so here we go. I need some extra colors to teach today. Let's see, let's go with orange, blue, and I like that tan brown color. It's nice. Alright, so we have 4 goals. Our first goal is to be able to use the triangle proportionality to set up and solve for missing side lengths. Second one is to be able to use the triangle proportionality to set up and solve for algebraic statements. The third is to be able to use parallel lines proportionality to set up and solve for missing segments. And then the fourth one is parallel lines proportionality with algebra. So when it comes to triangle proportionality, there are 2 theorems that we're going to be talking about. So this is goal 1. So our first theorem is the triangle proportionality theorem. All right, so this is happening, if you notice we have a triangle here. And within this triangle we have 2 segments that are congruent. So what this is doing is that it's breaking the triangle into proportional parts. So for example, we have this part here. Okay, and if you look on the other side of the triangle, it matches up with this part here. See how those match up? We'll call that A, and we'll call that B. So they can create a ratio. All right, and it's going to be equal to, well, if you notice, we also have this part here, and it matches up with this part over here. Say C over D. Another way you could think of it is A over C is equal to B over D. Means the same thing. If you remember in section 6.1 and 6.2 when we talked about being able to manipulate proportions. There's one more I want to talk about. If you notice, we could consider the entire side lengths. So that would be also equal to E over F. And this is a lot easier once you practice it with actual numbers being thrown in there and actual algebraic expressions being thrown in there. It's just all about finding what matches up with what to be able to create your ratios. Same thing if we're talking about the triangle angle bisector proportionality theorem. So this is talking about whenever your triangle is broken up into pieces because of an angle bisector. This one was broken up because of parallel sides. This one is being broken up because of an angle bisector, meaning it's cutting this into 2 equal parts. So it'd be like having this part of our triangle matching up with this part. Okay, so again, call that A and B. Okay, and it is equal to, the other part we have is this part matching up with this part. We'll call that C and D. I don't know if this blue is going to last me very long. One of the important things I want you to notice is that we're talking about like this triangle and this triangle. So it's like it's been broken into 2 triangles. The other part that we could be dealing with when it comes to the angle bisector proportionality is sometimes we deal with this entire side. Okay? It would match up with this entire thing here. Okay? Again, that will be easier to deal with whenever we are talking about numbers and things like that. It can't match up with what we have going on over here, but it would match up with if we did, say we did A over C. And you're like, well, how can that match up? So if A is talking about the side of a triangle, that would line up with F, because F is talking about the sides of a triangle. And if C is talking about the base of this triangle, well, E is talking about the base of that triangle. Okay, again, a lot easier once we start practicing it with actual numbers. Speaking of practicing it with actual numbers, let's talk about our first example. Now again, just like before, all of the examples that we're doing today in our notes are all actual questions on your homework. The other thing I hope you noticed is that if you're someone who wants to pre-write the examples before we do them, I did provide a set of blank notes. If you're someone who has an iPad or an iPhone, you can download that and you can actually write on that and you can submit that as your notes, okay? Let's see what we got going on here. Since my blue pen is not doing the one job it has in life, and that's working, let's move on to a different color. So it's all about seeing what matches up. So I always start with the thing I don't know. So I have my question mark right here. This is what I don't know. Question mark over. Okay, and let's see, what does it match up with on the other side? Well, it matches up with 9 is equal to, okay, we do know that this is 16, right? 16, and it matches up with, well, we don't know. We don't know what's going on over there, but we can find it by simply taking the entire thing, 21 minus 9, which gives us, why am I drawing a blank? Okay, I was off by 1. 12. All right, so now let's think back to 6162. How do we solve proportions? Why we use cross product property, which means we are going to cross multiply. So we're going to do, okay, 12 question mark equals 9 times 16. Handy dandy calculators are our friends. So 9 times 16. So we have 12 question mark, or you can use X if you want, if that makes it easier for you. I completely understand. And then we want to solve for our question mark. We divide by 12, and we get that our missing segment length should be 12. It's 12. And there we go. That's our final answer. So the difficult part or the challenging part or the actual geometry-based part that we're dealing with is the setup, being able to notice what matches up with what. So let's do another one. All right, so again, first thing I like to look for is my unknown, and just for the sake of making it easier for some of y'all, let's go ahead and call this one X, shall we? So we have X over, and you see, what does it match up with on the other side? Well, it matches up with 5. Is equal to, okay, we have 6. If you notice, I'm keeping the sides of our triangles together. Over, well, what does 6 match up with? 3. And just like before, we solved this using cross product property. So we're going to go across this way. So we get 3x equals 5 times 6. So we get 3x equals 30. We want to solve for x, so we divide by 3. And we get that our missing side length is 10. All right, that is 2 questions from your homework on the Google form. Your Google form has a total of 20 questions this week. So let's move on. So we've practiced the triangle proportionality when it comes to finding a missing side length. Let's practice the triangle angle bisector proportionality when it comes to finding a missing side. Okay, so first thing I notice is that our missing side is the entire thing. And remember, whenever we talked about the entire thing on our angle bisector proportionality, it matched up with the entire length here. So we need to find that. So if I wanted to find my entire length going on right here, I'm going to go, okay, 28 plus 16. I'm going to use the calculator, that way I don't mess up on my simple math. Equals 44. So question mark over 44 equals. All right, now I need to see who else is on this end with my question mark. Why 12 is. And then you're like, okay, well then do I line it up with 28? No. See how 12 is the only one we know? That means we need to be working with this triangle right here. Okay? So what's the side length that we know with this triangle? Why, it's 16. Again, it's all about matching up information. All right, and then we solve it by simply using cross product or cross multiplication. Again, I'm going to just substitute in an x for the question mark just to make it easier. So I have 16x equals 44 times 12. Again, use your calculators. That's why they're there. So we have 16x equals 528. Divide by 16 to get your x by itself. And we get our missing side length is 33. I'm afraid this orange marker is going to have to get thrown away as well. So I did for the markers. All right. It's all about matching up information. Okay? First, identify what you don't know. See what it matches up with. Here we go. Let's do another one. All right, so here's what we don't know. We don't know that question mark there. And who does it match up with? Y. It matches up with 12. Okay. All right, now we're going to talk about the side length that's with our question mark. That's 35. And who does it match up with? Y. It matches up with 20. And then we solve it by using cross multiplication. I think I might have another orange up in here. I do. Let's see if it works better. I'm going to substitute in x for the question mark. Oh, it's more of a peach. It works. So I have 20x equals, and then we have 12 times 35. Please use your calculators. So we have 12 times 35. So I have 20x equals 420. Then to solve for x, we divide by 20. And our missing side length is 21. Again, these are two questions that are on your Google form. So out of the 20, we've already gone over 4 of them. It's quite a bit. All right? All right. Moving on. Now, let's talk about triangle proportionality with algebra. The same concept applies here. It's just all about what matches up. For instance, if I'm talking about my 3x minus 4, it lines up with 6 is equal to, and on the same side as it is 28, and it matches up with 12. Again, we're going to use our cross product, so our cross multiplication. There's just going to be more algebra involved. This is the geometry part. Now we're going to do the algebra part. So using cross multiplication, we have 12 times 3x minus 4. Make sure you put that in parentheses. Equals 6 times 28. Now, this one's not as easy as the other ones when it comes to how quickly you can solve it. So the first thing we need to do is use our distributive property. So we're going to distribute this 12. So 3 times 12 is 36x minus 48 equals, I want to check my math on that, make sure I'm not being cuckoo for Cocoa Puffs. All right, and then 6 times 28 is 168. All right, so if we were to solve for x, and this will be the last example I do for you for part 1 of this video, so I'll start with, we're on goal 2, so I'll start on goal 2, the next example on the next video. All right, so we have our variables and our constants. So we have a 36x, so no other x's. We have a 168. We also have a 48 that we need to move over. So remember, if it goes across the line, we make it opposite. So 168 plus 48 gives us 216. Okay, to solve for x, we divide by 36. And we get that x equals 6. Again, this is a question on your homework on the Google form. So I've done 5 examples with you over the homework already. Out of the 20, that means everyone should at least get a 25% on their homework. All right, see you in a little bit for part 2.